So today is October 15th, and you're here for Econ 249. As you can see, we're going to continue with Chapter 7, all about normal distributions, and that's what I began in the last class. So in the last class, I talked about how the normal distribution is really the most commonly used distribution, and it's applicable to many different disciplines and industries. And it's all based on this symmetric model of a bell-shaped curve. And in the last class, we started doing a problem, and I would like to go back to that problem and redo it again, just so we come back to our thoughts on the normal distribution. But before I do that, now I said that since the normal distribution is so applicable to any example or any experiment, what we can do is we transform the x value into a z value, and that z value is the standardized value. But instead of doing that, we can also use the empirical rule, which is what you're looking at here. And the empirical rule is based on the standard deviations. So it says that 68% of all your data falls within one standard deviation, 95% of all your data falls within 2 standard deviations, and 99.7% of your data falls within 3 standard deviations. So this is a very cool theory that we can apply without actually transforming x into z. And that's what we did in the last class with this example. So I'm going to start today's class with this example again. So reading from the top, GMAT has scores from 200 to 800. Scores are supposed to follow a distribution that is roughly unimodal and symmetric, and is designed to have an overall mean of 500 and a standard deviation of 100. Now, why is this important? It's important because we need to know what you're dealing with. Are you dealing with a skewed distribution? If it is skewed, then you have to analyze it in a different way. But you're specifically told that it's unimodal and symmetric, which is one of the properties of a normal distribution. So now you know you're dealing with a normal distribution. And if that's so, then you need to have been given the mean and the standard deviation. You cannot continue without knowing mean and standard deviation with normal distribution. Okay, so that's given to you, 500 and 100. In any one year, the mean and standard deviation may differ from these target values by a small amount. We can use these values as good overall approximations. So the manager asks, a new applicant to our company earned 600 on the GMAT. Where does she stand among all those who took the GMAT? Now I know you have the answers here, but I want you to visually understand what it is you're trying to analyze here. So when you're trying to calculate probabilities to do with a normal distribution, the first thing you should do is draw your curve. So you, in the best way you can, draw a bell-shaped symmetric curve. And then mark your center. Your center is always going to be mean, population mean, mu. Now you were given in the question that the value for mu is 500. And then you were also given in the question that your population standard deviation is 100. So that means 500 plus 1 standard deviation plus 2 standard deviations plus 3 standard deviations would be 600, 700, 800, and then to the left 400, 300, 200. Okay, and you're told in the question that the manager wants to know, what percentage, sorry, this one. Where does she stand among all those who took GMAT if her score was 600? Okay, so here you have your value 600. This was our mean, right? Mu at 500. And so your manager wants to know how much better did this applicant do compared to everyone else who took the test. So in other words, what's the percentage, or what's the probability, or what's the area under that curve? Now, all these three things are the same thing. Percentage and probability is the same thing here. I'm looking at a curve, the area under the curve. The shaded area is what we need to get. Okay, so the idea is if you score 600, you did better than what percentage of people who took the test. Now, this is where we can apply the empirical rule. So the empirical rule is also called the 68, 95, 99.7% rule. So this rule is saying that, let me draw it here, within one standard deviation, so this is one standard deviation, 68% of all your data will fall within one standard deviation. And we also know that if this is a symmetric curve, and if I take it, split it right in the middle, in half like this, then I know that the area from all the way on the left, which would be negative infinity, up to 0, not 0, but up to the center, mean, that entire area would be 50%. How do I know that? I know that because the entire area under the curve is either 100%, that total probability is 1. Okay, so I know visually speaking, half of that is 50%. So again, just to clarify, I'm talking about just this half of the curve is my 50%. So now what I'm left with is trying to find the area from, let's choose a different color, center to that GMAT score of 600. So that's simple now. All I have to do is add up this little bit to the 50%, which means I can take my 68 divided by 2, which is what? Abraham, what's 68 divided by 2? Thank you. It's 34. Okay. So we have, write that here, 34%. Okay, so final answer would be, yes, Jonathan, how'd you get 84? Yes, 50 plus 34. Any questions for me? So this is just to show you that you could use the empirical rule without transforming our x values into z values. So you can see here we were still using x values. So we had 500, 600, 700, and so on. Ideally, you would transform those values into z values and then get your answer. But in this case, we were able to use the empirical rule and say that this person who got a score of 600 did better than 84% of the individuals who took the test. Okay, so that's really what we did in the last class. I'm going to move on, continuing with the same problem, but part 2 of the problem. So this question says, we have a whole new group of applicants with GMAT scores between 450 and 600. What percentage of all test takers does that correspond to? Okay, I know it says a polling question, but we're actually going to do it together. So again, first thing you should always do is to draw the graph. So that's what we're going to do. So here we've drawn the graph, bell-shaped symmetric. My center will have mean, right? That's the first thing I'm going to write, my mean of 500, and then plus 1 standard deviation, which is plus 100, so that's 600, 700, 800, and same thing on the left. Now the manager is saying applicants with GMAT scores between 450, so let's assume that's 450, and 600. So between those two scores. So the manager wants to know what percentage of all test takers does that correspond to? So what's the percentage between 450 and 600? So that's the goal in trying to calculate this. Now you can do this in many different ways. So Dong Yan, how do you suggest I start?
$68 divided by 2, so it'll be 500 to 600.
Okay, so let's do that first. So you're saying that I'm going to use the empirical rule, which is that within 1 standard deviation, 68% of all our data falls within 1 standard deviation. Okay, so then you're saying take half of
Yeah.
that. Okay, so let me
Yes.
mark that. That's half of that. So here I'm going to type 68 divided by 2, and you got 34%. Okay,
Yes.
then what?
And then we do the between 400 and 500. I mean, between 450 to 500. That will be 34 divided by 2.
Okay, so between 450 and 500 is those two. And we're doing this because we know this is a symmetric curve. We can do this kind of a thing. So now we already know what that little bit is, which is 34 divided by 2, which is equal to
17.
17.
Mhm.
Okay, and let's have Purushottam. What's my total percentage in the center here?
Professor?
Yep.
So be 17 plus 34%, so 51%, right?
Okay. Yes, so that is the answer, 51%. So that's using the empirical rule to get the answer.
Okay.
Thank
Thank you.
you. So, Karina, did you not understand something? So we got half of this based on our empirical rule, right? And so that's the 60, that's the 34%. Okay. This area to the left, so we still have to do this area here. That would be half of the 34. So this is saying, I don't know if you can see, it's 34 divided by 2, which is 17. So this area here is 17. So 17 plus 34 should give you 51%, which is this entire region. Okay. So far, this is not really difficult. It's really logical. It's nothing new that you need to know, but it worked out because we were looking at scores fell at exactly 1, 2, or 3 standard deviations, or exactly between standard deviations. So it was fairly easy to figure out using the empirical rule. But what if I said the manager got a gun with a GMAT score of 613 or 459? Now it gets complicated. So when you have values that don't fall on the standard deviation, then you have to transform it into Z, and then apply it. So that brings us to the next slide. When the standardized value falls exactly 0, 1, 2, or 3 standard deviations from the mean, we can use the 68, 95, 99.7% rule to determine normal probabilities. When the standardized value does not, then we look it up in a table of normal percentiles. So our goal today is to learn to read this table of normal percentiles, normal distribution tables. So that's what we're going to do for the rest of the time today, actually do a few exercises on how to read the tables. So tables use the standard normal model. So we'll have to convert our data to z-scores before using the table. So now all this time you will use X values, the GMAT scores. They were not Z values, they were X values. So in order to use a table, you can only use Z scores or Z values. These days, finding percentiles from a normal table is rarely necessary. Most of the time, we can use a calculator, a computer, or a website. Now, I will also show you how to get probabilities with the normal distribution using Excel. But before I do that, you need to understand where those numbers come from. So it's very easy to plug it into Excel and get Excel to pump out the answer. But you need to understand if that number makes sense. So that means because this is an introductory statistics course, you have to understand how to retrieve the number yourself by reading the table. So before getting into Excel, you need to understand exactly how to read the table. So now these tables are available to you in your textbook. It's in Appendix B, page A41 and A42. Okay, I will also upload these tables on MyLab under document sharing. Okay, that's where you get to see all these PowerPoint slides, right? Document sharing, course tools, document sharing. So again, for the rest of the time today, we're going to practice reading the tables. Now, the exercises I have just gives you the Z values. So right now, we're going to assume that you already transformed X into Z. The actual transformation is very simple. It's a very simple transformation formula, which I showed you earlier in this chapter. And I will actually do a word problem by transforming that later on. But today we're going to assume that X was already transformed to Z. So these are the exercises we're going to finish up today with. And I'm going to start with the first one. And I'll move on to the next slide because there's more room for me to write. So there's 10 exercises. This is the first one. So it says, find the probability when Z is greater than or equal to 0 and less than or equal to 1. Okay, so I'm reading the first exercise. Find the probability when Z is greater than or equal to 0 and less than or equal to 1. Now again, when you start doing your normal distribution calculations, the first thing you have to do is draw your curve. So get into the habit of drawing a bell-shaped curve. It does not have to be perfect, but try to make it look like it's symmetric. Okay, now I'm going to mark the values that are given. Z is between 0 and 1. Okay, so we know this is going to be 0. Now, because I'm dealing with a standardized normal distribution, Z, the center of this curve, will always be 0. The center will always be 0. That's my mean. Remember, the mean is always 0 for standardized normal distribution. And the standard deviation will always be 1. Okay, so mean, let me write it on the top here. Okay, I don't know why that happened. mean is always 0, and sigma, that's a comma, sigma is always equal to 1. Okay, so the next thing is marking the value 1. So let's say this is the value 1. And I need to find the probability, I need to find the area between 0 and 1. Okay, so this is the probability that I'm interested in, between 0 and 1. So there's one thing I can get immediately when I look at this graph. I know this is symmetric. I know the entire probability under the curve is equal to 50%, 100% or 1. So that means half this area should be equal to what value, Anna? So from negative infinity up to 0, what should that area be equal to? 50% or 0.5, okay? So let me put it as 0.5 this time. Yes. Now, what I need to find out, I know that you're comfortable with the empirical rule, but I'm going to show you how to use the tables. So I'm going to show you how to do that, but I'm going to also tell you that the table always gives you the area from negative infinity up to your z value. Okay, it always gives it from all the way to the left up to your z value. So I'm going to look up on the table from negative infinity to 1 when z is equal to 1. Okay, I'm going to write the answer first because I know when I come back to the screen, it's going to be erased. So I'm going to show you how this is the answer. 0.8413 is the area from negative infinity up to 1. Okay, so now moving on to the normal distribution table, and I'm going to actually share my slides. Or, no, I think I can do it on here. I have it here. Okay, so this is a normal distribution table. I can make it larger, but I just want to show you there's 1, 2, 3 pages. The third page we're not going to refer to as yet. This is the second page. This is the first page. Now you can see a bunch of rows and columns. Let me make this a little bigger. The column all the way to the right, it has all the negative values of z, our z value or our z score. They're all negative values. The center, in the center, you see a bunch of numbers. Those numbers are probabilities. Okay, so these are the different probabilities associated with the z-scores. The graph that you're looking at on the top left is your standard normal curve. Now remember, one of the properties is that the entire area is equal to 1 under the curve, or the total probability is equal to 1. Now remember I said probabilities are given from negative infinity. So let me write that here. It's not letting me write. Okay. From negative infinity up to the z value. So that shaded region is your probability. Now z is negative, so that's why it's to the left of 0. That's why all the values on that right column, it's all negative. If I go to the second page, this is the second page, first column has all the positive values of z. So you can see here, these are all positive values of z. The center of the table has all the probabilities. And see here that from negative infinity up to z, those are all the probabilities. This is the shaded area that you're looking at. And what else? So z is positive, so it's to the right of 0. Okay, so now let's go back to our question. And so going back to this first page. Let's go to the side. Sorry. So I said that we were looking at you had to find the probability when z is between 0 and 1. And we said that, I think I should draw it here somehow. So we had 0 and we had 1, and that's the area we were interested in. We said the probability up to 0 was 0.5. And I said that I had to find the probability from negative infinity up to 1. So that's what we're going to do now. We're going to look up the probability when z is equal to 1. So I'm going to go down. First, I'm on the second page of my normal distribution table. Why second page? Because z has all the positive values, and I'm looking for z is equal to 1. So when z is equal to 1.00, so this is my second decimal place, z has to be equal to 1.00. The probability is equal to 0.8413. 0.8413. So that means the area from negative infinity up to 1 is 0.8413. Now I can get the answer for between 0 and 1. I would have to subtract 2. And then what do you get for an answer, Brandon? Okay, thank you. The answer is 0.3413. Okay, so any questions for me? Okay, so that's how you would read the table and get your answer. You will be able to use this table for the exam, Diana, to answer your question. Okay, so going back to our exercises.
Professor.
Yeah.
I just wondering. See the one you say it's zero. Oh, I'm sorry.
Oh, sorry.
I'm just. It's okay. The second decimal is you say 0.00. What's the difference? 0.00 or
Okay.
0.01 or 0.2 like that?
Okay. So actually, let me share my screen. It's a little
Thank you.
easier than going back and forth. So sharing my screen. Okay, so let's go to the next page. So the second page, I said go to when z is 1.0, right? That's what we were looking at. Z is 1.0.
Yes.
And then how do I know which of these values to go and find across, right? I have to pick one
Yes.
of those. So this is when I would look up the second decimal place. Z is equal to 1.00. So since z is 1.00, I would choose 0.8413. So I'll do a few more and then you'll see when we use everything else. Okay.
Thank you so much.
You're welcome. So let's do the next one. So the next exercise is number 2, and that is asking us to find the probability when z is greater than or equal to -1 and z is less than or equal to 1. Okay, so again, first thing I have to do is draw my curve. Okay, so I'm doing number 2 right now. So I'm going to draw my curve here. My center is 0. So this is saying z is greater than or equal to -1. Okay, so let's make this -1, and z is less than or equal to +1. Now, some of you might recognize this and do it in a different way, which is fine. But the idea is to practice using the tables. So we're interested in the probability between these two z-scores, between -1 and 1. So again, the table is always giving me area from -infinity up to my z-value. Always from -infinity up to my z-value. So when I look up table, when z is equal to 1, what was my probability? That was actually the same answer as before. When I looked up z is equal to 1.00, what was that probability? Yep, 0.8413. Okay, so we know that already. Now I'm going to look up when z is equal to -1.00. So I'm going to write the answer first and then show you how I got from 0.1587. We'll check that. Yes, so 1587. And then what should I do after that, Arzu? Because I'm asked to find the area between -1 and 1. Brian? Yes, exactly. Arzu, can you give us that answer, please? Okay, I'm going to say 0.6826, which is also equal to 68.26%. Okay, you could have written it as a probability or a percentage. So remember, the empirical rule said that 68% of all your data falls within one standard deviation. So that's where the 60% came from. If you want to be really precise, you would use the normal distribution table and you would come up with 68.2%. So I'm going to show you now how I got the 0.1587 in the table, but it's the same method, okay, by using the empirical rule. Okay, so we're going to look up to see how I got this area. So the area from -infinity up to -1, right? That's the area I'm talking about, just this area here. Okay, so sharing my screen. Don't know what is easier. I guess it's the same thing. Okay, so the first page has negative values of z, which is what I want. So I'm going to scroll down till I look at the right side column when z is equal to negative 1.0. And the second decimal place is also 0 because it's negative 1.00. So that probability is 0.1587. So it's telling me that from negative infinity up to that negative z value of minus 1.00, that area is 0.1587. So that's how I got that. Any questions about this? So it's important to recognize that you have to subtract the two, right? You can't just end by getting the probabilities because the table always gives us from negative infinity. Okay, so moving on. Brad, you have a question?
Yes, I just want to ask. So the reason we subtracted is because negative one is, I mean, sorry, the 0.1587 is a negative number.
The
Because
reason
negative one minus 0.813, it's a negative number. Is that why we subtracted it?
that's not the reason why we subtracted. So let me quickly show you here. We subtracted because we got area from negative infinity up to 1, right? We got that as 0.8413.
Right.
And then the area we got from negative infinity up to negative 1 was the 0.1587. We needed,
that's the area from the left to up to that
right,
point. Okay.
right. And we needed this center area, so that's why we subtracted it, so we could get that center area.
Okay. All right. No
Got
problem.
it?
Thank you.
Okay. So now I'm going to clear this, and we're going to do problem number 3. I think this is, yeah. So first thing, what should I do? David? So I'm looking at question number 3, and it's saying find the probability when z is greater than 0 and less than 2. What's the first thing I should do when I'm dealing with normal distribution? I should always draw the curve first. Okay, thank you, Priscilla. Now this question is slightly different from the previous question. Do you see something different? Do you notice anything? Diana, what's different? Gilbert, yeah, so there's no equal sign. There's no equal to sign. Yes, Diana. So this question is saying z greater than. The other questions had this equal sign here. So if I put greater than or equal to, or if I had not anything, it actually doesn't matter. With normal distribution, it doesn't matter if the sign is less than or equal to or just less than. If the sign is greater than or equal to or just greater than. Does not matter. I know that when you're doing your homework binomial distribution, it does matter because either you include the value for x and you include that probability or you do not. And you have to be very careful with binomial distribution. But with the normal distribution, it doesn't matter. Okay, so I drew my curve and I mark 0 because I'm told we're interested from 0 to 2. So let's say this is 1, this is 2. Okay, so I'm going to mark this as 2.00. And I'm interested in the area between the two. So all this area. Okay, same way we've been doing, nothing's different. I already know the area from negative infinity up to 0 is what, Erica? So from negative infinity up to 0, Yes, we know that is 50% or 0.5. So I can write that here, that's 0.5. Now I'm going to look up in the table when z is equal to 2.00. I'm going to give you the answer first. When z is equal to 2.00, I should get this value, 0.9772. And Eliyahu, what should I do after that? So I've got the area from negative infinity up to 0. So this is negative infinity up to 0. I've got the area from negative infinity up to 2. Eliyahu, what should I do? Hiba? Yep, subtract 2. Jeffrey, what's the answer you get? So you switched it. Priscilla? Dongyan, the answer. So let me type that in here. 0.9772 minus 0.5, 0.4772. Yes. So I think you got it. And I'll just show you where I'm getting the 2.00 from in the table. Okay, any questions before I switch over? No questions. Okay, so going to my table. Now this is the wrong page because z is negative here. So I'm going to my next page where shows z as positive. I go down to when z is equal to 2.00. Second decimal place is also 00. And that's where I got 0.9772. So remember, it's the area from negative infinity all the way up to when z is 2.00. It's all that area. Okay, so that's 0.9772. And that's how we applied it in that question. Okay, so moving on to the next exercise, and it gets slightly different now. So number 4 says probability when z is greater than or equal to 0 and less than or equal to 1.96. So now it's slightly different. We're looking at a different second decimal place. Again, doesn't matter if I'm dealing with less than or equal to or greater than, doesn't make a difference. Okay, what should I do first? Hira? Yes, so Diana said we draw the curve. So we draw the curve. Again, this is how you should be doing it when you do your homework. The center is 0. So this is saying find the probability when z is between 0 and, so between 0 and, assume this is 1.96. So yes, the table is in the book, but I also loaded the tables on MyLab, so you can access it. And
do we need to show you at any point, Professor, the drawing of the bell curve, or can we just use the other method that we know?
Say it again. What's your question?
Do we need to show the bell curve at any point
No.
on the test?
You don't have to show it, but
Okay.
It helps when you have these second decimal places, and I'll show you why now.
It's more accurate, yeah. Okay.
So we have to continue in the same way where you find the probabilities from negative infinity up to the z value. So I'm going to start with that. From negative infinity, which is on the left here, going up to 1.96, I need to find that area. Again, I'm going to give it to you first because when I come back here, everything is erased. So from negative infinity up to 1.96, the area should be 0.975. What's the area from negative infinity up to 0? Yes, so that's 0.5. So Jamera, what should I do next? subtract it, and then what do you get as an answer? Q 0.475. Okay, so now I'm going to show you how did I get 0.975 on the table. Okay, any questions about this before I switch over? So I'm getting these numbers because the question is telling me from 0 to 1.96, right? So that's where I drew my graph from 0 to 1.96. And then I got my areas. Okay, so switching over to the table now. Okay, let's delete these things. So I am looking for z equals 1.96. So I'm going down to my left-hand column, going down to z equals 1.9. That's right here, 1.9. And then going to the second decimal place of 0.6, because it's z equals 1.96. That gives me a probability of 0.9750. Okay, so now we've used a different decimal value rather than 0. Again, it's giving me the area from negative infinity up to z, when z is 1.96. Questions for me? Okay, moving on. So now let's do the next exercise, which is number 5. So number 5 is saying find the probability. You can do this now because we don't need the table. I draw my curve. This is 0 from 1. So let's say that's 1 to 1.96. Okay, and I am asked to find this area between the two. Okay, so let's start with Oscar. What should I do first? Quasi? Oscar, you say find infinity to negative 1.9. Okay, let's go with that. So from negative infinity up to 1.96. Now we did that already. We just looked it up and you said that it's equal to 0.9750. Okay, so we have that. Quasi, what should I do next? Rachel? Oscar, you told me then minus negative infinity 1. Okay. So infinity to 1 is that value. And we did that here. Right? What's negative infinity to 1.8413? Okay. So I'm going to write that here, 0.8413. And then finally, since I'm interested in the area between the two, Tusha, you said the value is 0.1337 or 13.37%. Okay, any questions for me? So it's pretty simple now, you're getting it. I'm going to move on to the next exercise. So the next exercise, I'm going to skip question number 6, okay? And I'm going to do question number 7 instead, because if you get question 7, that means you've got question 6. So question number 7, slightly different now. It says find the probability when z is greater than 1.64 or z is, sorry, let me say that again. Find the probability when z is less than 1.64 or when z is greater than 1.96. So again, even though the question is slightly different, we're going to draw the graph first. Okay, so here I draw my bell-shaped curve, which is kind of symmetric here. My center is 0. The first thing I'm going to mark is 1.64. So let's say this is 1.64 and this is, so exaggerating it a bit, 1.96. Okay, and now I need to figure out how to shade this. So the question says less than 1.64. Less than means I shade to the left. So less than 1.64 means everything to the left of 1.64. And the question says greater than 1.96 means I shade to the right of 1.96. Okay, so now I have to find my areas or my probabilities. So let's start with from negative infinity up to 1.64, and then let's look up when z is 1.96. Okay, so the 1.96, we just did it, so I can write that answer here. From negative infinity up to 1.96, that answer was 0.975. Yes, thank you, Ying. But the concern is that's not exactly the purple shaded area, right? So, Rad, you're correct. You can do it that way too. The purple shaded area is not 0.975. I don't know what this area is. What exactly is that area? How do I get that area? 0.975 is from negative infinity. I would have to do 1, which is the area under the curve, minus the 0.975, and that will give me what? 0.025. Yes. Any questions about this? Does everyone understand why I had to subtract that? Make sure you understand. That's why it helps to draw the curve, because this is telling you that what you just found on the table when you looked up z equals 1.96, it was the area from negative infinity up to that z value. So purple shaded area, you still had that 1 minus that area. Okay, then when you look up in the table, as z equals 1.64, you should get 0.9495. Okay. So now we have the yellow area and we have the purple area. That's the last step. Add, okay. And then if I add it, Veronica, what do you get as an answer? Yes. So, Julia, to answer your question, it would be 1 minus that, because we're interested in the area that is shaded, right? Yeah. Okay, so I don't know if I can copy this. Let's see if it allows me to do some of this stuff. No, I can't. Okay, so I really need you to visually remember this so that I can go back into the tables and show you where I got these numbers from. So I just want to show you in the table where I got 0.9495 and where I got 0.975 from. Okay, so I'm going to go to the tables now. Yes, Dong Wang?
Yeah, Professor. I was wondering because the before 1 minus 0.975, that one I just didn't get. Yeah, I'm sorry. Can you explain again, please?
Okay, so let me go to the table.
Okay.
I think it's probably better if I do that. So let me quickly go
Okay.
here. Actually, I'll do it with sharing a file. So not the first page. I'm going to go to the second page because the second page has negative values. So first, my curve said, that's not very good. Let's do it again. My two values were 1.64, 1.64, and 1.96, right? Okay. And then we said greater than is to the right and less than is all this to the left. Okay. So when I look up 1.64, 1.6 is here, go across to 4 is here, right? 1.64. So that means from negative infinity up to here is 0.9495. Okay, then we said when z is 1.96, z is 1.96. So go down to 1.9, second decimal is 6. That area is this, 0.9750. The problem is 0.9750 is from negative infinity up to 1.96. It's not this area. You see, so that's why we have to do, in order to get this area, this purple area, I still have to do, I need to get this balance here. So that's why I do the 1 minus 0.975.
Yeah, I get that. I just
Okay.
wondering why it's 1 from the 1
Okay.
to
Because
subtract.
the area under the curve is 1.
Oh,
So remember,
okay.
this
Oh,
entire
okay.
area is equal to 1.
Okay, got it. Thank you.
Okay. You're welcome. So now we finished that exercise. Let's go back to the other one. Okay, so now okay, so we did number 7, right? We're doing number 8 now. So this is slightly different. This is saying where you're given the probability, you have to find the z value. So the probability is 0.3413 when z is greater than or equal to 0 and less than or equal to some unknown number. I'm going to rewrite this as a lowercase letter z so that you don't confuse it. Okay, so z is between 0 and some unknown number. The probability of the area is equal to 0.3413. So again, you're going to draw a curve. You do it the same way you've been doing it. And we're doing it this method, so it's easy to visualize. So your center is 0. For any standardized normal distribution, it's yellow. You're told that between, so 0 and a number, okay, so between 0, so this is 0, 0, and some number, which we don't know, this is the unknown number, and we're going to call that unknown number that lowercase letter z. That area you're told already is 0.3413. So you need to find out what's the z value. Okay, so now we know that the way to find the z value is to look in the table. And we also know that the table only gives us the value from negative infinity. Do you have any suggestions how I should do this?
Find the negative to 0 first.
Okay, so from negative infinity up to 0 would be what?
0.5.
Okay, so that's 0.5. Okay, and then
add 0.5 with the 0.3413.
and you get
0.8413, so it will be 1.
okay.
Z equal to 1.
Okay, so then that means we have to look up in the table, in the middle of the table for 0.8413, and we should find it at 1.00. So let's see if that's what happens. Okay, any questions before I switch? Okay, so maybe take a picture of this if you want. And I'm going to look in the middle of the table for 0.8413 and try to find it at a particular z value. So looking in the middle of my table, it can't be in the first table because this has all the negative values of z, right? So all negative values of z. So I would have to go to the next table, and I'm trying to look for 0.8413, and I find it here. And it's not that complicated to look for it because there's a particular order. So when I find it, I'm looking for the corresponding z value of 1.00. So that's why z is equal to 1.00. So in order to get 0.8413, you need to draw the graph and go through those steps. Okay, so moving on to the next exercise. Okay, so number 9 is saying, again, probability is given to you, 0.9744, but you don't know what this z value is. So you're told that z is less than or equal to some unknown value, and the probability is 0.9744. Now again, a reminder that if it says less than or if it says less than or equal to, it's the same thing. You can disregard it with the normal distribution. And again, a reminder that you're looking at z, not x. Okay, it has already been transformed. Okay, so first thing we're going to do is draw the graph. But now there's a bit of a problem. So I'm going to draw 2 graphs and ask you which one I should pick. The question is saying z less than some number, and that number is unknown. So if this is that unknown number, then this is z, and less than means I shade to the left. So I shade to the left. Okay, let's see if that's right or wrong, Priscilla. And I'm told that the area, when z is less than that number, that area is equal to 0.9744. Okay, but I don't know if z is positive or negative. So what if z is negative? And what if we assume the unknown is this negative z value? Again, less than means I shade to the left. However, I am told area is 0.9744. So now I have to decide which curve to choose. Which one should I choose and why? Should I go with a negative z or a positive unknown z?
Should go positive.
Ying, you say positive. Dong Yang, you say positive. Why positive? Want to explain, Ying?
Because negative infinity to 0 gonna be 0.5. So 0.9744 is greater than 0.5.
Yes, I agree. We already know that from negative infinity up to 0 here is already 0.5. So this does not make any sense to have this area as 0.9744. So z cannot be negative. Does not make sense. So we're not going to go with that. So this is telling me that z is positive. That's how I know that z is positive. This makes sense. 0.9744 is greater than 0.5. Okay. So now all I have to do is look up in the table for 0.9744, and in the middle of the table, because I'm given the probability at 0.9744, corresponding z value should be 1.95. Okay, the corresponding z value should be 1.95. Any questions before I show you that? Okay, so let me quickly go here. I'm looking for 0.9744 on the positive normal distribution table. This is the positive table. I'm looking in the middle for 0.9744. And I see it right here, 0.9744. The corresponding z value is 1.95. 1.95. Questions for me? Questions? Okay, we have one last exercise to finish up today's class, and that's problem number 10, which is saying find the probability when z is between 1.4 and 2.5. So this is really simple, right? Now you know how to do this. I draw my curve, and I'm going to exaggerate it a bit here, saying this is 1.4, and this is 2.5. I'm supposed to find the area between two. What should I do, Tyrese? Jeffrey, you say look up the values for 1.4 and 2.5 and then subtract them. Exactly. So if I look up when z is equal to 1.0 and then go across to the second decimal place of 4, when z is 1.4, I don't have those values. what is it, 1.49192. Okay, so this is 0.9192. And then when z is 2.5, what's the answer that you get, Mihrit? Maria, do you have an answer? Perfect. Yes. So I could write it this way, or I could say 7.5% if you had a true or false answer. Okay, so make sure you're aware that you're finding probabilities, percentages, areas. Be comfortable in recognizing. So again, in the next class, we will be using Excel and we'll do a full-blown word problem where we transform X into Z. Now that you understand where these numbers are coming from and how to read the table, it's going to make more sense. A reminder that your Excel number 3 assignment, your team assignment, is due on Tuesday. Same method, right? Put it in a Word document and upload it onto Blackboard. You can access all the lectures online on Blackboard under course materials, okay, in case you're not aware where to see this. So you can always go back and review this stuff. Any questions for me before we end class today? You're welcome. So I'm going to stop recording.